we have to solve an initial value problem. Notice that we have a differential equation, and then we have also a condition. So that is why we have to solve an initial value problem. So notice that this equation is given in the form m of x comma y dx plus n of x comma y dy equal to 0. So since the equation is given in this form, then it could be or could be not exact equation. So we should check if the condition for exact equation is met. So the condition of the exact equation states that if the derivative of n respect to y is equal to the derivative of n respect to x, then the equation is exact, and then we can use the method of exact equation to solve it. So now notice that in this problem, m of x comma y is that expression multiplying dx. So in this case is cosine of 2x cosine of 2y plus e to negative x. So this is n. Okay, so what is n? N is that expression multiplying dy. So n of x comma y is negative sine of 2x sine of 2y minus 1 over y. So this is n, which is that expression multiplying dy. So it is time to find the derivative of n respect to y and the derivative of n respect to x, and then check if these two derivatives are the same. So the derivative of n respect to y, then if since this is a partial derivative of n respect to y, is a partial derivative, then x is going to act like a constant. So all derivatives are going to be on y. Any expression, anything containing x is going to be acting as a constant. So the derivative of n respect to y is going to be simply, well, we find the derivative of just cosine of 2y. So cosine of 2y, derivative of cosine of 2y is going to be minus cosine of 2x. So cosine of 2x is like a constant, so remain the same. Derivative of cosine of 2y is negative sine of 2y times the derivative of the inside or the argument of cosine of 2y. You need to apply the chain rule in this case. So we're going to have the 2. Derivative of 2y is 2. And the derivative of e to negative x with respect to y is 0, because they are acting like x is acting like a constant. So in the same manner, we find the derivative of n with respect to x. So everything containing y is going to be like a constant. So we find the derivative of n. So we're going to just find the derivative of sine of 2x. So it's going to be the minus states the derivative of sine of 2x is cosine of 2x. Then we find the derivative of the inside of the sine. We need to apply the chain rule. The derivative of 2x is 2. times sine of 2y. Because remember, the derivative is on x. And then the derivative of negative 1 over y is simply 0, because 1 over y, since the derivative is on x, then it's acting like a constant. So notice that this expression is the same as this. So we can conclude, so these two expressions are the same. So since they are the same, the one in pink, the equation is exact. So the given equation is an exact equation. It is an exact equation. Therefore, we can use the method of finding solution of exact equations that consist of finding a function f of x comma y equals to c, equals to a constant. Now, how are we going to do that? So we have two different ways to find the solution of an exact equation. So that means that we need to compute function f of x comma y using the integral of the expression of m, the integral of n in terms of x plus some function depending on y, or find the integral of n, this time respect to y, plus dy, plus g of x. Let it change the notation. Something depending on x. Why is that? Well, recall that n is the differential of that function f of x we're finding respect to x, and n is the differential with respect to y. So we have to integrate as indicated in any of these two methods. So we can use any of these two ways to find the solution of an exact equation. So I'm going to use the first one, but the second way conduct to the same answer. So we're going to find the integral of m, the integral of m plus some function depending on y. Well, we have that m is cosine of 2x times cosine of 2y dx plus dy. And also there is one term missing, is plus e to negative x. So here one term is missing, plus e to negative x dx plus some expression depending on y. So in computing this integral, we obtain that f of x comma y is sine of 2x cosine of 2y divided by 2. Recall here we're going to find an integral of that expression depending on x. So for example, cosine of 2y is going to be like a constant, like a number. So that is why the integral of cosine of 2x is sine of 2x divided by 2. Cosine of 2y remains intact. And then the integral of e to negative x would be e to negative x e to negative x divided by 1, by negative 1. So that negative we can put it in the front. Plus g of y. Then, so this function is the solution, but it's not complete yet because we don't know what that function depending on y is exactly. So we have to compute, we need to find in some way g of y. So how are we going to find that? Well, now we can find the derivative of that function we found with respect to y, and that, recall, is going to be equals to n of x comma y. Okay, so the derivative of the function f is equal to the expression in front of dy in the given differential equation. So we need to differentiate the function we found, the f of x comma y, and then we equal it to n of x comma y. So let's do that. So in finding the derivative, the partial derivative of f respect to y, we obtain that this derivative, since it's going to be respect to y, so we find the derivative of just cosine of 2y, which is negative sine of 2y times 2, because we have to multiply by the chain rule of the derivative of the inside of the cosine. So we have negative 2 sine of 2x sine of 2y. Okay. This sine of 2y is coming from finding the derivative of cosine of 2y, which is minus. The minus we wrote in the front, divided by 2. Plus 0, because the derivative of negative e to negative x is simply 0, because e to negative x depends on x, and the derivative we're finding is on y. Plus g prime of y. G prime of y. Then that is going to be equal to n of x comma y. So we can simplify that expression. So we have sine of 2x sine of 2y, negative in the front, 2 and 2 cancel, plus g prime of y, that is equal to n. And what is n? N is negative sine of 2x sine of 2y minus 1 over y. So this n is that expression multiplying the one in blue, that expression multiplying the y. So this term and this term are the same, so we can cancel them. So we have g prime of y is equal to negative 1 over y. So we integrate both sides. So g of y is equal to negative ln of absolute value y. Okay, so this is the sequence. So we're now moving up. So our solution is going to be what? It's going to be sine of 2x cosine of 2y divided by 2 minus e to negative x plus gy, and then uy happens to be negative ln of absolute value y equals c. Okay, remember the solution is of the form, this form. Solution is of this form in green. So the solution is like this. But since this is an initial value problem and a condition is given, then the condition is y at 0. Y at 0 is equal to 1. So we replace 0, then we have sine of 2 times 0 times cosine of 2 times 0 divided by 2. That's going to be 0 because sine of 0 is 0. And then we have e to 0, which is 1. We have basically 0 minus 1. Then ln of y is 1, and the ln of y is 0. So we have with minus, and then from here we conclude that c is negative 1. So our solution, the solution for the initial value problem is sine of 2x cosine of 2y divided by 2 minus e to negative x minus ln of absolute value y equals to negative 1. So this is actually the solution of the initial value problem.